And
Thank
now we're
you.
just going to pretty much go right into Harris's talk. Um,
Thank you.
now, unlike Chris, who I've known for a while, I've recently met Harris, and I've met him just by, again, like I met Leah, just kind of keeping aware of people who are doing very interesting things and saying very interesting things. And in a particular case with Harris, really if you look at his background, one of the things that really speaks to me is this notion of game theory and game design. And I have, a lot of interest in serious games and game theory and the game theoretic aspects of what participatory budgeting can do and be. I don't know if you're going to even bring that up, Harris. It's not at all required, but I'm going to give your brain time to warm up, because I may throw you a couple of questions when you're done about that. And we are very thankful that you're here with us. And we are very excited to get your perspective in kind of this field that we're in together. So thank you very much.
Well, thanks a lot. It's a pleasure. I'd like to thank you and also Ari for the invitation. Let me just try to share my slides. Share screen. All good?
Yeah, this is going to be great. And just as a side point, you've got a bunch of the dev team here, Harris, and we talk about this internally at FirstRoot. If I said a lot, they would probably laugh at how much we talk about this notion of the fairness. And I've got some notes about how we can express fairness more effectively. So I can't wait to hear what you're going to talk about. Take it away.
Okay, that's great, because that's one of the angles I'll mention in this particular presentation. So again, I'd like to thank you and your team for the invitation. Most of us, most of my work is, I'm a theoretician by training. I'm a computer scientist, and one aspect that I'm really interested in is working on aspects where computer science can contribute to social good. And as Luke mentioned, I'm really interested intellectually in this aspect of fairness. So as a lot of decisions are made by computers nowadays, how can we ensure fairness of these decisions by computers? And also the same aspects also apply to humans making decisions, or decisions being made by humans in collaboration with a computer. So I'll mention that a bit in my presentation as well. But overall, it's really exciting to be part of this conference, because I also attended one of the early lectures, and this angle of participatory budgeting as an opportunity for education and decision making by kids. That's really exciting and very inspiring. So since I was asked where exactly I am, so let me just give you a couple of photos. So I'm currently based at UNSW Sydney. This is right on the eastern side of Sydney, and just nearby is Coogee Beach, which is not too far away as well. But if I was to locate my work in my research area, I basically work at the intersection of mathematics, computer science, and economics. And one particular academic community that I'm especially work in is called computation social choice. And social choice itself is viewed as the theoretical foundations of this issue of collective decision making, or voting, or decision making. And the reason why computational social choice has come to the fore is that a lot of these decisions, or a lot of these aspects, are now being aided by computers. And as a trained algorithm designer, a lot of researchers in this field, they try to design algorithms to aid collective decision making. And indeed, participatory budgeting is one of the most interesting and exciting aspects of collective decision making, especially as you know, a lot of political institutions have a lot of inertia, and changing how things work is not that easy. But on the other hand, a lot of aspects in participatory budgeting can be already done at a so-called low stake, but much more grassroots level. And this really is an opportunity to try new things and use a lot of new innovative ideas in this area. So the previous presentation had a lot of inspiring quotations. I at least have one. So I start with a very provocative quote by Pia Mancini, who is an Argentine activist and politician. And she asked, if internet is the new printing press, then what is democracy for the internet era? And indeed, in the last decade or two, many new exciting democratic paradigms have come to the fore. For example, liquid democracy is one thing which has been mentioned in the last decade. But participatory budgeting is one aspect which has already caught on quite a bit. It's employed in hundreds of cities across the world, is used to decide on city budgets in the scale of millions of dollars. So I just had a few representative aspects here, but something which is even more local is the same program has also been started a couple of years ago in New South Wales, the state in Australia where I reside in. The project is called My Community Project. And the idea is, again, to take input from residents about what their preferences are over which public projects should be funded. And based on these preferences, funding decisions are to be made. So I didn't mention it before, but please feel free to interrupt and unmute yourself and ask me questions whenever needed. Okay, so as far as the plan of this particular presentation is concerned, it's a bit more academic, coming from an academic. My plan would be that I'll introduce one model of participatory budgeting with ordinal preferences, which I've been working on. I'll discuss the interplay of participatory budgeting with a very well-studied academic field of social choice theory or voting theory, which has been around for more than half a century. And as Luke mentioned a bit on what fairness aspects are in this context, I have a few ideas as well in this line of work. So I'll present some of my ideas on this. Especially, I'll present some work which is jointly with one of my PhD students, Barton Lee. I'll mention that paper later. And in that particular paper, we worked on this idea of how to conceptually formalize what fairness or proportional representation is in this context, and what kind of methods can we employ for participatory budgeting. And finally, I'll mention a few other formal models of participatory budgeting, which are also quite important. All right, so before I proceed, collective decision-making has been around for centuries. In particular, what is called single winner voting has been around for a long time. Greeks and Romans used to do it as well. So the idea is to express preferences over social alternatives, political candidates, public projects, and so on. And the requirement in this particular model or this particular application is simply that you want to select a single alternative. So in this context, one very famous and very widely used method of decision-making is called the plurality vote, or first past the post. And the idea behind plurality is that, as many of you know, is that you simply care about which alternative gets the most number of first positions, and that particular alternative is to be selected. So in this case, you have 9 voters, and B, C, and D all get first position twice by 2 voters each, whereas as you notice, voters 1, 2, 3, they most prefer alternative A. So from that point of view, if you just care about the first positions, then alternative A would be selected. But somebody might say that actually A is not an amazing outcome, because it's actually the worst outcome for 6 of the voters out of 9 voters. So how do we make sure that we come up with a reasonable outcome? Well, there is no right answer to this question, but at least people have been thinking very deeply about this issue. So rather than just reason about which method is good by looking at outcomes, what people have been doing is they have been thinking about it from a very principled point of view. They've been formalizing axioms. So this axiomatic method, especially in voting theory, became quite prominent uh, due to the work of people like Kenneth Arrow and Amartya Sen, both of whom happened also to be winners of the Nobel Prize in Economic Sciences. So that's something which I also use, this method of the axiomatic method, where instead of just looking at the outcome and seeing, okay, which particular method gave a good outcome, you really try to care about what essential properties a collective decision-making method should have, and then try to design methods or identify methods which may do well in terms of satisfying those formal requirements. And particularly, multi-winner voting is another setting, which is a generalization of single winner voting. And in multi-winner voting, instead of just selecting one particular alternative, you may want to select a target number of alternatives. So it's more general than single winner voting. And the moment you have this flexibility of selecting multiple alternatives, then the space of methods which you can use to select desirable outcomes, it also becomes very rich. And there's a lot of work on how to make decisions regarding multi-winner voting, how to make sure that the requirements or the preferences or the goals of various participants is respected. What exactly is fairness in this context? These are very deep questions, and people have been thinking about it for a long time in political science and mathematics, economics, social choice theory, and now even in computer science. So one thing I want to mention here is that if participatory budgeting is viewed as selecting a set of public projects that need to be funded, then immediately what we notice is that participatory budgeting is also an exciting generalization of a very well-studied field of voting theory, which is called multi-winner voting. And the reason is that if all you need is you have a budget, and every public project or every project that you want to select has a unit cost. So every project has the same cost. Then essentially what you're trying to do is you're trying to select a certain number of projects. And if you're just selecting a certain number of projects, that's just the same as multi-winner voting. So the reason I mentioned this particular aspect is that this already shows that quite a few of the ideas which are being used in multi-winner voting, we can try to generalize them or directly apply them to come up with somewhat desirable methods in participatory budgeting. On the other hand, participatory budgeting also involves various new features. There are obviously certain projects might be too expensive. Different projects may have different costs. And how do we take all of this information into account to make principled decisions? That's quite an interesting intellectual question as well. So one particular model, so since I'm a mathematician by training, I will gradually try to formalize some of these aspects in a very formal way. So when I talk about participatory budgeting, I just want to make sure that we're on the same page. So one particular model that I will talk about is that of participatory budgeting, in which voters express rankings over projects. And we just want to select a certain set of projects which meets the budget limit. So the setting is that voters are expressing ordinal preferences or just rankings over public projects. And the goal is to select a feasible set of projects which is within the total budget limit. And we want to do it in a so-called fair manner. And what I mean by fair is obviously up for debate. I will also ask you for your suggestions. But the question that we have been looking at is, in terms of research, is how do we formalize fairness in this respect? How to formalize proportional representation in this context, and how do we achieve it via an algorithm? So some of the ideas that I will mention today are based on a very recent paper which was written with Barton Lee, who's my co-author on this project. He's just finishing up his PhD in economics, and he'll be moving to Oxford for his postdoc. So as you can see, there's already, even in this two-author project, there's a lot of collaboration between different disciplines. I'm a computer scientist by training, and Barton is an economist. So Regarding this particular project, I just want to mention a few related works. People have looked at participatory budgeting in various aspects when you're talking about academic literature. So when you talk about participatory budgeting, first thing you mention or you take care of is what is the input format of the preferences of the voters. So one very famous or widely applied input format is that of approval ballots. So when people simply approve of a certain set of projects and they simply ignore the rest of the projects, which is assumed as they not approving those projects. So when the input format is just approval ballots, I just mentioned a few representative works which have looked at fairness in this context. There's also a lot of work on welfare focus. And what I mean by welfare focus is when you try to maximize the so-called happiness of the voters in some way, whether as in terms of a utilitarian aspect, where you're just trying to add the utilities of the voters, or in some kind of egalitarian perspective, where you care about the happiness of the worst of voter. So this is especially the case when you take a very utilitarian point of view, and that has been the case in a few works. For example, I mentioned a few representative papers here in the third bullet point. Especially want to mention this Ashish Goel here, who's mentioned in a few of the works. He leads a very nice team in Stanford who is also working quite a bit on participatory budgeting projects and using some ideas from game theory, decision sciences, and social choice, and also help deploy participatory budgeting systems, especially in cities across America. Finally, there's some work on fairness in the respect of very different model where you're doing some sort of portioning of the budget. So here it's not a very discrete model where projects have costs, but you're just trying to decide on some long-term decisions about, okay, this much funding we want to put on education, this much on development, this much on sports, and so on. So that's a very different model, which does not explicitly involve cost of projects, because all you care about is long-term planning of how much portion of budget should be given to different categories. So it's not about selection of discrete projects for the next year. So one starting point for this particular research paper of ours was that many of the existing methods in participatory budgeting, they are utilitarian in some respects. So what do I mean by utilitarian or majoritarian is that they try to find the best projects according to certain methods. And these methods, sometimes they do not necessarily take into account representational concerns. So there might be situations where a minority of voters, that minority is quite cohesive, and they really want a certain project which is important to them to be selected, but it's sort of that you are taking people's preferences into account. So you are asking them for their preferences, but those preferences are not truly respected in some way. So what do I mean by that? I'll explain with the help of an example. But that was one of the starting points of a research project, that we want to care about fairness in a formal sense. How do we formalize it, and how do we achieve it? That's one of the questions that we've been looking at. So again, I want to mention that the model that we're looking at is inspired by this My Community project in NSW, New South Wales. And in this particular project, what people do is they actually give rankings over projects. And based on these rankings, you want to select a certain set of projects. So here's a formal model of this problem. So what we have is you have a set of voters, you have a set of candidates. I also have some notation which essentially just captures this information that each voter has expressed their rankings over each of these projects. Since we're doing participatory budgeting, it also has a budget limit. We do not want to exceed the limit. We can't exceed the limit. And obviously, each of these candidate projects, it has its own cost. The model that I have used with Barton, it also involves a voter weight of each voter. But in most contexts, you can just assume that each voter has the same voter weight. But in some contexts, you might have situations where, let's say, one voter is representing a whole set of voters. So in that case, you might give that voter more weight. So, and essentially we're just finding a set of outcomes. So a set of outcomes from the set of projects. And what we want is that the weight or the cost of this particular set of selected projects does not exceed the budget limit. So I won't scare you more with mathematical notation. I just want to quickly build some intuition with the help of an example. So this is an example which is very simple. It's an example with just 9 voters. And let's say you have 4 projects, A, B, C, and D, and each project has cost 1 except, let's say, project A, which let's say has a cost of 4. And let's say the budget limit is 3. So which particular project we should select is up for debate. There are different methods which give different answers, but I just want to mention this particular example so that you're clear that what the input format is. So as far as fairness is concerned, people have been thinking about fairness for a very long time. It's already in some ancient Greek texts as well, what exactly is ethics and what exactly is fairness. But a more modern version of representation, or rather proportional representation, is that each political party in a parliamentary system should have representation which is according to the number of voters who voted for them. Obviously, in participatory budgeting, we don't put people in separate boxes and then just ask them to be affiliated with one political party. It's everybody can vote as individuals. So in that case, how do we take these preferences into account to have a very similar sort of principle where your number of people who vote on a certain outcome, it does matter. So when you talk about fairness in voting or collective decision making, I mentioned once quote by John Stuart Mill that the first principle of democracy is representation in proportion to numbers. So we've tried to take this general principle into account, but when you want to formalize it in the context of participatory budgeting, it's not that trivial. But just want to mention that even in the context of multi-winner voting, which is a simpler setting in participatory budgeting, it does not involve any budget limits. It does not involve project costs. There's already a lingering concern among various groups that a lot of voting methods or a lot of voting systems or political systems are sort of broken because people raise this issue of minority representation, or the fact that preferences of voters is elicited but not truly represented. Even in the context of participatory budgeting, I'd like to mention one particular report. It's a World Bank report on one of the first successful applications of participatory budgeting, which was in Brazil. And even in this particular report, which I can share with you later after the presentation, it does mention that one of the key indicators of how well a participatory budgeting program runs in the city or a town is based on this, at least this perception that if there's a minority group, their concerns or their goals are taken into account when making these funding decisions. So what are these fairness concerns? What are these representation concerns? Let me just give you a very simple example. This is an example with 100 voters, 4 projects, and let's say it's a very simple example where every project has the same cost. And let's say 51% of the voters most express A1, then A2, and then A3. And 49% of the voters, they most prefer B1, B2, and B3. So just think of the preferences in the middle of the slide. In that case, many of the participatory budgeting methods, they may fund just A1, A2, and A3. So from that point of view, if let's say there are systems across the world which do that, the question I want to ask is that, is it fair if A1, A2, and A3 are selected? And if you do that, then 49% of the voters, they do not get any project that they express preference over. Is that fair or not? So that is one of the starting points of the fairness concern. And obviously, at least some people might say that maybe 49% of the voters should have some representation in the set of selected projects as well. Another slightly more complicated example is here we have 9 voters. Again, we have 4 projects. And let's say each project has the same cost. And the budget limit is 3, which means that we can select 3 projects. So again, which project should be selected? That's quite up for debate. There's no right answer. But one particular concept that has been around for at least 20 years is called proportionality of solid coalitions. I will mention who proposed it, but it's a very general and very nice principle, and that has been proposed in the context of multi-winner voting, not participatory budgeting, which does require that A and B should be selected, at least A and B should be selected among the 3 selected alternatives. And the reason is simply that voters 1 to 6, they constitute 2/3 of the number of total number of voters. And from that point of view, they should at least have some say over at least 2 of the alternatives that they select. And since A and B are the most preferred alternatives that they have, maybe there's a case to be made that A and B should be selected. So I'm not saying that this is the principle or the only principle to make proportional representation decisions, but this is one concept that has been quite prominent in some of the academic literature, but not really discussed so much by practitioners or people who are actually deploying systems, especially voting systems. So this concept that I'm mentioning here is not even in the context of participatory budgeting, it's simply in the context of multi-winner voting, which, as I mentioned earlier, can be viewed as a restricted version of participatory budgeting in which each project has the same cost. So who proposed this particular concept? Well, it was proposed by an Oxford philosopher, Michael Dummett, who was referred to by Daily Telegraph when he died as one of the most significant British philosophers of the last century, and also, incidentally, a leading campaigner for racial tolerance and equality, which is one of the values of this particular community, and also one of the core values of participatory budgeting overall as well. So a couple of books have been written by Michael Dummett on these aspects, especially he's discussed this concept called proportionality of solid coalitions in his books, and also considered some methods which may achieve this axiomatic property. So one of the aspects of how to define this proportionality of solid coalitions is this intuition that a certain set of voters cohesively have some preferences over a set of alternatives. In this example, voters from 1 to 6, they all, in fact, have unanimous preferences over these social outcomes A, B, C, and D. So the reason why we can say that 1 to 6 solidly support A and B is because the voters from 1 to 6, they most prefer A and B, and these alternatives A and B are more preferred than the remaining alternatives. For this reason, this aspect that they cohesively most prefer those alternatives over all other alternatives is the reason why we mention that as solid support. So since if a voter or a voter group solidly supports a set of candidates, we might want to take that solid support into account when trying to include certain alternatives. So since voter 1 to 6 solidly support candidates A and B, we might take that into account while making the selections. We might try to select A and B if possible. Taking the same example a bit further, how do we take this example and handle this example when you move from multi-winner voting to participatory budgeting? Things become a bit more complicated. Firstly, when I talked about cohesive preferences, I was not talking about unanimous preferences. So it could be the case that a group of voters may have similar but not unanimous or identical preferences over social outcomes. It could be this case that 1 to 3 have preferences A, B, C, and D, and maybe 4 to 6, they have preferences B, A, and C, and D. So a group of voters may have similar but not identical or unanimous preferences. Another complication that can arise is that there may be ties in the preferences. That's actually already the case in many participatory budgeting systems where, let's say, agents or voters, they express approvals. And when you express approvals, you're essentially expressing that you are indifferent among all outcomes which you have approved. Thirdly, I did not mention this before, but the moment you move from multi-winner voting to participatory budgeting, you also need to take into account the affordability of the preferred projects. So if, let's say, voters 1 to 6 most prefer alternative A, but alternative A is so expensive that it's going to take up all the budget, maybe it's not a great idea to select alternative A. So we really need to take into account how expensive a particular public project is before making these decisions. And finally, another complication that may arise is the group of voters can be combined with many different groups of voters. So I'm not talking about already preset set of voters. There are no political parties. There are no preset set of voters. All we're asking is for individuals to express their preferences. But while taking these individual preferences into account, we may want to take into account group dynamics. And that is what we're trying to do while capturing proportional representation. So
when you say group dynamics, this is super fascinating for me personally, because my work has been in creating small group collaborative participatory budgeting processes that scale. So for example, when I'm working with large corporations and we're doing portfolio management choices, we never have an individual vote. We will take, so the rule of thumb is between 5 and 8 participants, because we know that human collaboration doesn't exceed, you can't really exceed 8 actors and have a highly collaborative group. So if you give me 40 people, I'm going to create 8 groups of 5 people and have the groups discuss amongst themselves what the choice is. And to be candid, we've been having a fun time as a team in Slack talking about some of this really powerful stuff that you're sharing, because the thing that I always worked on in my last company, and we're getting into real-time collaborative discussions on voting. And so when you said the group activity, that's a really important distinction. My mental model of most of the mathematical work associated with this kind of analysis is assuming non-collaborative behavior among the voting actors, meaning the voting person gets a ballot, I submit the ballot, it's my ballot, it's my private. But are you now suggesting that this particular branch of math is actually real-time collaborative behavior? Because that usually involves a whole set of social and psychographic trade-offs.
So the mathematical model that we have, it does allow for voter weight. So even if you have groups of different sizes, you can ascribe a common, after a lot of deliberation, you might have a commonly agreed preference of that particular group. And if, let's say, the groups have different sizes, you can have a voting weight which is proportional to the group size.
That's really fascinating. Okay, keep going. I'm just going to say that's really exciting stuff. And our team is going to really dig into that. But this is great. Keep going.
And yeah, thanks for your question. And secondly, one thing which I'm mentioning here is that this proportionality of solid coalitions extension that we're going after, it provides a coordination device among people who may not even know each other, but they may have similar concerns. So what we want to respect here is that there might be people in different parts of the town, they don't know each other. And sometimes it's not even that easy to bring them onto the same table. But if, let's say, there is a big enough group, a minority group, which cares about a certain issue, and let's say that particular issue or that particular project that they're going after is not as expensive, it's cheap enough to be in the budget limit, that we want to respect that kind of situation when you have a set of voters that is large enough, that cohesively prefers some projects which are cheap enough. We want to respect that situation. We want to select some projects which are cohesively preferred by that group. And
well,
I'm not for.
What if you took the group membership up that maybe existent a priori And in the collaborative activity, you mixed up the members of the different groups. So one way to look at this is let's say there's a geography of a given city. In American cities, and I'll speak to what I know in American cities, we have a city that's organized in districts, and the districts are organized in neighborhoods. So one way to construct a representative group of people is representative by a district, right? I live in this district, and presumably individuals who live in a certain geography are going to have somewhat similar views on something. So a way to construct this interaction so that you're maximizing collaborative interactions is to say, at this table of 5 people, we are going to explicitly include one member from each of the 5 districts, under the assumption that they probably are walking into that real-time collaborative event with presumably different preferences. And then through the act of the conversation, some person will go, oh, and partly I've seen this in my work in the real world and doing budgeting like this in San Jose, where people from affluent neighborhoods had very different perspectives from people who were living in gang-infested neighborhoods, until they heard the stories of the gang infestation, and they immediately changed their mind because they had more information that was generated through the collaborative activity.
Absolutely. So this concern about various neighborhoods having their own goals is not a problem at all, even if you bring them together. So sometimes, in fact, it's often the case that if you make the participatory budgeting small enough and local enough, that's good for deliberation, but it may be inefficient because you may not be able to pool in resources for some common project which affects, let's say, 2 neighborhoods rather than individual neighborhoods.
Yeah,
so as long as some of these representational axioms are satisfied, then different groups or different districts or different neighborhoods, they do not have to have any concern, even if they join in for a larger participatory budgeting program, because this axiomatic property that I'm going to mention in the coming slides, it ensures that in some individual district, or even let's say a small group within that district, if they have some issue which is only affecting them and not anybody else, that concern will still be represented and they will get their due share in the outcome. So that's the kind of thing that we're trying to capture in some of these mathematical formulations. So I mentioned a few of the ideas, or at least I'm trying to give you some intuition by these ideas, that let's say if voters 1 to 6 cohesively like A and B, then we try to take that into account, especially if A and B are not that expensive. So a few complications do arise, but based on these challenges, we did come up with a mathematical axiom, which I think it's probably better that I immediately go to a more intuitive version of that, or an informal definition of that axiom. And this particular axiom is essentially one extension, or a carefully chosen extension, of the famous axiom of Dummett, the Oxford philosopher, who only formalized it in the context of multi-winner voting. And we've done it in the context of this more complicated participatory budgeting paradigm, where you may have ties, you may have project costs, you have budget, and a lot of other aspects as well. So it captures these issues which Luke mentioned as well. So the idea behind it is very simple. It's the idea is that whatever outcome you have, it should satisfy this intuitive principle. And that principle is that there should be no set of voters. So we are not enumerating all these set of voters. We are just defining a property. And if we satisfy this will happen, that there will be no set of voters. This set of voters may not have to coordinate with each other, but we just avoid any set of voters who solidly support a set of projects C prime. By solid support, I simply mean that they prefer all of these outcomes in C prime over all other outcomes. And based on the deserved proportion of the budget, we already know what the deserved proportion of the budget would be based on the number of people in that voter set. They can additionally afford to include another project from C prime. So that's the idea. It's a very simple idea that if you take any set of voters, based on how big that group is, you know how much proportion of the budget they should have at least a proportional say in. They can also have a say outside it that will also be taken into account, but at least this much proportion of the budget they should have more of a say in. And if that's the case, that we have this hypothetical budget that is only applicable for that set of voters, you do not want to have a situation that their hypothetical deserved budget was not fully used. They could have used it for selecting one additional project from their cohesively supported set of projects, which is C prime. So still a bit of a mouthful. But at least it's an intuitive aspect that we're trying to take into account cohesiveness of a voter group. We're trying to take into account the size of the voter group, and we're trying to use these basic ideas to make sure that all of these voter groups, they get enough representation. So that's the idea behind what we call inclusion PSC. And what we did was we showed that this particular axiomatic property in voting theory, often there are some properties which you may define. They're quite nice to define, but you can't actually achieve them. So this property is meaningful enough because it's a generalization of a very well-founded and well-established concept in a restricted domain of multivariate voting. It's well defined in this more general context. And in fact, there always, for any problem you take in participatory budgeting, there always exists at least one set of outcomes or set of projects which satisfy this representation axiom. And in fact, we also, in our paper, we summarized an algorithm or a voting rule for this particular axiomatic property. It's not the only voting rule which satisfies this property, but so I'm really trying to sell the property more than the rule, but we also gave one particular rule which does satisfy this property. And if, let's say, some system is deploying this kind of representation, then this particular axiom might be something which might be taken into account while making these decisions. So our particular method, it works as follows. We go down the voter list, and if there is some candidate that has sufficient support from the voters, we select it. Sufficient is obviously not fully formalized in this informal slide. By sufficient, I simply mean that if it has enough support based on the number of voters, and if that particular candidate is cheap enough, we select it. I won't go into the formal details of this particular method. I have, in fact, the next slide, or one of the next slides, has the pseudocode for that as well. But I just want to mention that there does exist one method which carefully, what it does is it goes down the preference list. If, let's say, a candidate is supported by a lot of voters, and if that candidate is can be added into the budget set, we do add it. And the moment we add it, we essentially reweight the voter weights of those voters who have already been represented a bit. So for example, if that candidate was supported by a set of voters and that particular candidate project has been selected, then all those voters who supported that particular project, their voter weight goes down to make sure that we don't take into account only that particular voter group while making decisions. If we keep on reweighting those particular voter weights, then essentially some other voters whose weight has not gone down, they may also be represented. So that's an intuitive way of capturing representation concerns, that we don't always care about majority. We all obviously care more about the majority while making some decisions, but we don't ignore the minority completely. So that's the general idea behind some of these axiomatic properties and also some of the voter rules. So just like to mention here that this is just one particular way of capturing proportional representation. When people talk about axiomatic properties, there are lots of other ways one can capture it, and all of this is up for debate. There's no right answer, but I think what is important is that we do take into account this issue that just by asking people for their preferences and then saying that, okay, we are implementing some democratic methods may not be enough. We might want to make sure that some groups who do express preferences, but then their favorite projects are never selected, let's say over a certain number of years, we might want to take that into account, because what we don't want is dissatisfaction, or we don't want is people moving away from these systems. We in fact want the system to grow, or we want these participatory programs to include more people over time rather than lose people. So just because I mentioned this voting method, I quickly go over this particular example. This example was this running example where you had 4 projects and 9 voters. This particular method, which we have come up with, it would, in the first round, it would just consider alternatives A, D, and C, because they are the first or the most preferred alternatives of the voters. At that point, we see that there is not enough support for the alternatives, so we just go down the voters list. And when we reach the second round, which is when we can focus on the first 2 most preferred alternatives of each of the voters, then based on certain calculations, we can identify that B and C can both be selected. And at that point, we can select them. And after that, this rule, it continues until the budget has either exceeded or no other project can be added to the budget set. So I won't go to the technical details of a pseudocode or an algorithm. The main takeaway message that I wanted to have was that people have been caring deeply about axiomatic or formal properties of voting methods. The same kind of approaches can be used for this very exciting and interesting paradigm of participatory budgeting. And I just wanted to mention one particular method that we identified and one particular axiom that we identified. I really encourage people to think more about these properties when they're deploying their systems as well. So one other reason that I want to mention why this aspect of PSC or inclusion PSC is very important is because I just assume that the public projects are already there and people are making decisions. This is a very limited way of thinking about participatory budgeting, as many people here are deploying the system. They know that, in fact, the deliberation part or nomination of projects is as important as this formal method of aggregating the preferences and selecting a project. But I just want to mention here that even if we care a lot, or we want to take into account the deliberation part or the nomination part, what is really nice about this axiomatic property, which is called inclusion PSC or PSC, is that it provides a degree of robustness to a lot of strategic things which people can do when making these nominations of projects. So one thing that has often been taken into account in voting is this concern that if you clone projects or just create some other projects which are very similar sounding, it can have a big impact in which alternatives are selected. Similarly, for the same public project, you could either split that project into smaller projects with small budgets, or you could just combine certain projects and make it a bigger project. By doing so, it can have a very different impact. So what PSC or this inclusion PSC does is that it's sort of robust to these kind of changes. So it still ensures that if, let's say, a group of voters cohesively prefer a set of projects, then they will get their representation, irrespective of whether those projects are merged or split or they're cloned. So this is very important when making these representational concerns, even if you take into account this earlier stage of deliberation and nomination. Okay, just want to see how am I doing with time. I think it's, I still have a bit of time. So I just want to mention a couple of other models which people have looked at as well. I was simply talking about one particular model, and I mentioned one axiom and one method. Participatory budgeting is very broad in that sense. There are lots of other ways you can do participatory budgeting. One aspect that we have been working on is called portioning. In portioning, you don't really worry about cost because you're thinking about long-term contributions. So in that case, all you care about is decisions about, we just want to make 1/3 of the budget go towards education, 1/3 for public parks, let's say 1/6 for this category, and so on. We are not really selecting very concrete and particular projects. For that perspective, there are different axioms, there are different methods. So just mention a couple of works that at least I've been involved in, but there are lots of other works as well. Yet another model where people have been working on, especially in my community, is that of preferences over budget distributions. So the reason why I distinguish between portioning and budget distributions is that sometimes you don't just care about what proportion of money is given to your particular favorite category. Let's say if somebody is working in education, they might not just care about as much budget going just to education. They might in fact have a target ideal distribution of budget, which is a certain number of percentage going to this category, a certain number of budget percentage going to this category, and so on. So that's a very different model of expressing preferences. And even for that model, people have been coming up with methods which satisfy desirable axiomatic properties. So I've just mentioned one particular paper in that respect. And this particular paper is quite nice because it also ensures that no voter has an incentive to misreport their voter preferences. Typically in voting, it's very hard to incentivize people to always tell the truth. Sometimes they do express their preferences in some such way that they may get a better outcome. But in this case, truthful aggregation is possible. Okay, so just to conclude, in this particular presentation, I tried to capture some of the ideas that I have been involved in, especially in some of my academic research. Many people care about aggregation, collective decisions, but typically it's only in academia that people talk about axiomatic methods. So I just wanted to at least give a flavor of some of the things which people in social choice theory, computational social choice, and some of the more formal communities deal with. They try to come up with these axiomatic properties, and they use these axiomatic properties as guiding principles for coming up with new rules. So they don't judge a particular rule by one particular example and seeing whether that particular example gave you a good outcome or not. They try to think more generally in terms of, for any example or any participatory budgeting problem that you may encounter, can we come up with methods which provably or give a mathematical guarantee that they will always give a certain representation guarantee for minority groups. At least we made a case in our research paper that this axiom IPSC is meaningful and computation tractable as well, because you can reach it by computation tractable algorithm. But obviously, the model that I've considered is just one representation of participatory budgeting. Real life concerns are way more complicated, as Luke would attest to. There are so many other constraints, so many other distribution issues that need to be taken into account as well. And I mentioned a few of those. So I've already mentioned a bit on deliberations and nominations. That needs to be taken into account as well while building a real world system that is truly democratic. Secondly, there are lots of problems where, in fact, you don't have a public budget or a pool of money that is to be used for making decisions. You often have a case that individuals are also asked to make the individual contributions. So crowdsourcing is another aspect, which is a very exciting thing, which is quite closely connected to participatory budgeting. And if you're doing crowdsourcing, then a lot of new issues come up as well. For example, if let's say one person is contributing much more towards the common pool, then maybe that person's say needs to be respected a bit more as well. Is that true? Maybe that's the case in certain situations as well. So especially when you're doing crowdfunding or pooling in resources for making decisions about some charities, you may want to take into account both the preference of a person who is expressing preferences over the charitable donations, and also take into account how much donation that person has made towards this common pool. Another thing that I mentioned already was that you may care about budget distribution. So you may not actually care about a certain set of projects. You may have some ideal distribution that you think this is the right way to distribute the funding. Another thing that is often done in real world systems is matching contributions. So it's not the case that you just have a static pool of money. There are lots of companies who may say that, okay, if if this amount of money is contributed or is already accumulated, then we may match it and we might double it for a social good project. And that brings in its own challenges, how to model it, how to uh, uh, address it from a software engineering point of view, and so on. And finally, the model that I had was still quite simplistic, that people just have linear preferences over public projects. But obviously, when you're selecting a set of projects, things are actually in real life are much more complicated, because you may have preferences over different parks, but you might not want to just fund two parks in the same neighborhood. You might want to save some money for a different category and a different project. Some projects may have some interaction or synergy between each other. So let's say if you select one project and another project as a whole, they may have much more social benefit than just selecting one of the projects. So you might want to take these synergies into account as well while making these public decisions as well. So this concludes my presentation. I think I've left too less time for questions, but hopefully we can have a couple of discussion points. I thank you for your attention, and hopefully I was able to communicate some of these ideas which might be just embedded in academic communities a bit wider. And I'll be very happy to interact with you in the next few minutes and also in the future as well. So thanks a lot for inviting me, Luke.
Wow. I'm just going to speak on behalf of at least two members of my team, which is me and Sam. We totally geek out on this stuff. I mean, like, this is the kind of reading that I love to do on Saturday mornings. So I thank you so much for your talk. Like I said, we have I'll be totally candid. We've got a private Slack channel going with some of the engineers, and we've talked about these notions of what are the social implications of how we're putting together PB programs in schools, so that we can talk about these concepts in a way that students would understand them and be able to prepare themselves for civil society. And what does it mean to participate, and how do these preferences are known so that we can create government? I mean, yeah, it was very challenging, as Eduardo said. So Harris, I think you're going to see more of us, and I'm just going to put it on the record. If you need a system or to test out some of these theories, and you find that our system that we're building may be helpful in academic research, you would have we would be thrilled to collaborate with you and look at some of the mechanisms and some of the actors. We've done some research out of Karlsruhe Institute of Technology with Niels Feldman about can you, in a sense, engage in certain psychographic profiling of actors before they join in the voting, and what effect does that have? Not in the public sector, but in the private portfolio management sector. So for example, if I were to take the actors and run them through a Torrance a model or a Curtin adapter innovator scale to understand their preferences for structure and problem solving, and like how does that affect the group deliberation? How does that affect the quality of the result? So this is, sorry, I'm going to be quiet and turn it over to other people, but this is super fascinating stuff. Thank you so much.
Thank you for the invitation. I just like to mention that this perspective of yours for use or for everyday use is also for schools. I think this everyday use is really powerful. I think the same approach can be used for, let's say four housemates are sharing an apartment, and they want to, let's say, use some of their funding for some common appliances. Somebody prefers a gaming console, somebody else prefers something else. How much do they contribute? What decisions are made? I think all of these are everyday examples of how this participatory paradigm can be used for even everyday decisions as well.
We hope
within
that
a family, within a household, within a school, and so
yeah,
on.
Harris, I'm going to take an action, and we've got a version of our software coming out for families, and the specific areas of participatory budgeting that we want to promote in families are planning a family vacation, planning charitable donations, and planning home improvements, and also using it as an educational tool. Children can be very confused by the behaviors of their parents if the parents don't talk about it. So they see mom and dad take a loan to get a house, and they equate that with mom and dad can get money for the things they want from a bank. And then when mom and dad say, well, we don't have enough money to go to this exotic location for a vacation, and the child hears mom and says, well, why don't you just get a loan? And mom and dad say, well, no. If they don't explain the reasons behind that choice, then the children are confused. If you can correlate that with financial literacy training at the moment they're making those collaborative choices, you get a real benefit in terms of using these techniques within a family or within roommates or whatever, but you're also creating a really different narrative about how to communicate the means and the impact of choice. So this is really great research. I really thank you so much. I just have to say thank you again.
Thank you so much. And just one final comment I'll make is that although I'm a computer scientist by training, I just want to emphasize that often people have been thinking about these issues in a different community for decades. So it's interesting or fascinating how one can use ideas from one field, philosophy, that can be applied to political science, and then it can go to computer science and vice versa. I think it's very fascinating. And it's good to have an open mind and just seek out for good ideas from other communities.
Thank you very much.